Imagine you are sitting across from a deeply frustrated parent.
Oh, yeah. We have definitely all been there in this field.
Right. They are exhausted, they're near tears, and they look you dead in the eye and say, the aggression is worse. My kid is hitting just as much as they were a month ago. This isn't working.
And as the behavior analyst, you're sitting there knowing the intervention is actually working.
Exactly. Because you've been tracking the data every single day.
Yeah.
You know for a fact that the frequency of the hitting has been cut in half.
But you can't just tell them that. Human memory is entirely subjective.
Yeah, it's heavily influenced by stress and whatever just happened that morning, so you have to prove it. And you cannot prove it by handing them, like, a spreadsheet full of tally marks.
Oh, absolutely not. That's just overwhelming.
And you certainly can't prove it by quoting some statistical p-value at them. You have to draw them a picture.
Because without that visual representation, behavior change is just an abstract argument. We rely so heavily on visual analysis because it forces the data out of, the theoretical realm and puts it into a concrete reality for everyone.
Welcome to today's deep dive into behavioral intelligence con Mara Sánchez. I'm your host, here to help break down the complexities of behavior analysis.
And I am your resident expert, ready to get into the weeds of the science with you.
Today, we're exploring section C10 of the BCBA Foundations, which is all about graphing behavioral data to communicate quantitative relations. We've pulled from a really dense stack of sources today.
Yeah, we're talking BCBA mock exams, advanced study guides, and of course the foundational ABA text by Cooper, Heron, and Heward.
So our mission today is to cut through the behaviories. Whether you are actively studying for your board exam or you're just fascinated by how human behavior is measured, we're going to decode these lines and bars.
It's so much more than just dots on a page. Graphing is the ultimate tool for us to visualize behavior change and actually communicate results clearly.
Okay, let's unpack this. Why is the field of applied behavior analysis so fiercely dedicated to visual analysis? I mean, every other scientific discipline hides behind incredibly complex statistical modeling.
Right, they use all these algorithms to prove their interventions work.
Exactly. But behavior analysts just insist on plotting dots on a piece of paper. Why?
Well, it comes down to a fundamental philosophical difference in what we consider significant.
Significant how? Like mathematically.
Sort of. In many fields, you can run a massive data set through an ANOVA or a regression model. And if your sample size is large enough, you might find a statistically significant effect.
Right, the math says it worked.
Exactly. But when you look at the actual real-world impact, what we call clinical significance, the change might be so minuscule that it doesn't actually improve the person's quality of life.
Oh, I see. So it's a statistical win, but a real-world nothing.
Yes. Visual analysis is intentionally, unapologetically conservative.
Meaning, it doesn't really allow you to fake a victory. The change has to be so obvious that it practically hits you in the face when you look at the graph.
That's the goal. If we connect this to the bigger picture, the entire design of visual analysis is about transparency. Cooper and his colleagues really highlight this.
Yeah, they say graphing provides an immediate continuous visual record, right?
Exactly. You don't wait for a 6-month trial to end to run the numbers. You plot the data session by session.
Which gives you this real-time feedback loop.
Yeah, it allows you to explore behavioral variations as they happen. It acts as a direct judgment aid.
And it encourages independent evaluation, right?
Okay.
Like anyone from a clinical director to a paraprofessional to a parent can just look at the visual data and make their own judgment.
Totally. And it's so fundamental to the integrity of the practice that it's actually codified into the rules.
Oh, right. The ethics code.
Specifically, Section 3.01b. It actually mandates the collection and graphical display of data.
So it's literally the ethical standard of practice. You cannot make a treatment decision based on a staff member just saying, oh, I feel like they had a pretty good week.
No, you can't. The graph is the ultimate source of truth in the room.
So to establish that truth, you need the right canvas. And the absolute workhorse canvas of ADA is the equal interval line graph.
It's the most common tool for a reason. Equal interval graphs are designed to show absolute changes in behavior over time.
Meaning the distance between the intervals on both the time axis and the measurement axis is completely consistent.
Right. So a change from, say, 5 to 10 instances of a behavior looks exactly the same visually as a change from 50 to 55 instances.
It gives you a highly standardized view of those daily or session-by-session fluctuations.
And when an analyst looks at that data path, they aren't just looking at a squiggly line. They're looking for the big three.
Ah, the big three of visual analysis: level, trend, and variability.
You got it. Level is just the value on the vertical axis where your data points are converging.
Like, are we talking about a behavior happening 80 times a day or 2 times a day?
Exactly. Then you have trend, which is the overall direction the data path is moving. Is it increasing, decreasing, or is there a zero trend?
Just a flat trajectory. And then the third one is variability, which is basically the bounce, right?
Yeah, the bounce.
Yeah.
How tightly clustered are those data points, or are they just ricocheting wildly from one extreme to another?
And the interaction between those three elements is where the real diagnostic power lies.
Take functional analysis, for example. That's where we manipulate environmental conditions to figure out the why behind a severe behavior.
The sources gave a really clear clinical example of this that I loved. Think about a client named Anatoly.
Okay, yes. Anatoly engages in severe self-injurious behavior.
Right. And when you look at his equal interval line graph, you see different data paths for different conditions.
So the lines for the play condition, the alone condition, and the attention condition are all basically flat.
Yeah, the level is at 0, the trend is 0, the variability is 0.
But then you look at the data path for the academic demand condition.
And the level instantly spikes to like 90% occurrence.
Right.
It's incredibly stable at that high level as long as demands are present.
And that low variability across conditions, combined with that stark high level in one specific condition, makes the function undeniable.
Anatoly engages in the behavior to escape demands. The graph isolates the variable perfectly.
It really does. But then you have a client like Elena.
Oh, right. Elena's functional analysis graph is a mess.
Visually, yes. The lines for play, attention, alone, and demand are completely tangled up.
The data points are just zigzagging from 10% to 80% and back down again across every single condition.
The variability is massive. No clear trend or distinct level emerges for any specific trigger.
For a novice, that graph looks like a failure, right? Like bad data or a lack of experimental control.
But that is the crucial insight here. In a functional analysis, high variability and undifferentiated data is not a failure. It is the answer itself.
Wait, really? How is a tangled mess the answer?
Because when the behavior occurs at a highly variable, elevated rate, regardless of what the environment is doing, whether you're placing demands, giving attention, leaving them alone, it strongly suggests the behavior is maintained by automatic reinforcement.
Oh, I see. The behavior is producing its own internal sensory consequence.
Exactly. The environment isn't controlling it, which is exactly what that chaotic variability on the graph illustrates.
Which brings us back to that frustrated parent we talked about at the very beginning.
Right, the one sitting at the table.
You're looking at a line graph of their child's aggression over the last month. The parent says, the hitting is still happening. Nothing has changed.
And you look at the graph, the level shows that, yes, the hitting is still occurring at about 10 instances a day.
And there's still bounce variability from day to day.
Yeah.
So what part of that triad do you point to prove that the intervention is actually working?
You point to the trend. Trend is the absolute most powerful communicative tool for showing progress over time.
So you just show the parent the overall direction of the data path.
Yeah. You say, I hear your frustration, and you are right. The hitting hasn't stopped. The level is still above 0. But look at the trajectory.
3 weeks ago, we were at 30 hits a day. 2 weeks ago, 20. Today, we are at 10.
The bounce is still there, sure, but the trend line is definitively moving downward.
It visually isolates the broader effect of the intervention from the noise of, like, a really bad Tuesday.
Exactly. It provides objective proof of momentum.
Trend really cuts through the noise. But there's a fundamental limitation to equal interval line graphs, right?
Oh, for sure. They are incredibly powerful for that granular day-to-day analysis.
But if you're trying to present a long-term summary, say, 6 months of data across multiple environments, a line graph with 180 fluctuating data points is just going to look like visual static.
It becomes way too noisy to interpret effectively. To solve that, analysts have to basically zoom out and use entirely different formats.
And that naturally leads us to bar graphs.
Right. While the line graph is the analytical workhorse, the bar graph or histogram is the executive summary.
They intentionally sacrifice the display of day-to-day variability, right?
Yeah, in order to highlight the macro-level differences in level between specific phases or categories.
The mock exam sources highlight a great scenario with a BCBA named Kelly.
Oh, the biting behavior case.
Yeah, she's tracking a child's severe biting behavior over a 90-day period. If Kelly brings a line graph with 90 zigzagging points to an IEP meeting with the school district, and the parents.
The audience is going to completely get lost in the daily peaks and valleys.
Right. They might fixate on one really bad spike from 3 weeks ago
Yeah.
and completely miss the overall progress.
Exactly. The daily variability obscures the broader narrative. So Kelly collapses that data into a bar graph.
She just creates 3 simple vertical bars representing the total or average biting incidence per month.
Month 1, 56 bites. Month 2, 43 bites. Month 3, 17 bites.
By removing the daily data path, the bar graph makes the comparison between those 3 distinct time periods instantaneous.
It's undeniable. It's the perfect tool for communicating with stakeholders who just don't need the minute-by-minute breakdown.
But what if you aren't trying to summarize progress? What if you're trying to find a hidden pattern?
Like a behavior that seems completely random.
Yeah, and you need to figure out exactly when the environment is triggering it. That requires shifting from a bar graph to a scatter plot.
Scatter plots serve a highly specialized function. They map the temporal distribution of a behavior.
So you aren't connecting data points with a trend line, and you aren't calculating an average.
No. You are simply plotting a mark on a grid every time the behavior occurs. Time of day is on one axis, and the days of the week are on the other.
It functions exactly like a heat map.
That's the best way to think about it.
There was a clinical example in the sources where a parent is dealing with a child who suddenly starts running around the house screaming at the top of their lungs.
And it feels totally unpredictable to the family.
So instead of trying to time the duration of every single scream or count the frequency, the analyst has the parent use a scatter plot.
Just placing an X in the corresponding time block.
Right, and after a week, a pattern emerges. The analyst looks at the grid and sees a dense, dark cluster of marks right around 11:30 a.m. and another dense cluster right around 2:30 p.m.
While the rest of the day is virtually blank.
The scatter plot just performed all the heavy lifting of the assessment.
Exactly. Instead of the analyst sitting in the house for 8 hours a day, 5 days a week, waiting for the screaming to happen, the scatter plot pinpoints the exact antecedent windows.
The analyst now knows they need to observe the environment just prior to lunch and just prior to nap time.
It isolates those variables. Hunger, fatigue, or transitions associated with those specific times. It tells you exactly when to look so you can figure out the why.
That's brilliant. But there is another fatal flaw with equal interval line graphs that we need to talk about.
Okay, let's hear it.
It happens when you are trying to track long-term skill acquisition. Think about it. If you're tracking the mastery of new spelling words or the cumulative number of functional communication signs a client has learned, a line graph will completely lie to you.
Oh, I see where you're going.
Yeah, if a client learns 5 new signs on Monday, 2 new signs on Tuesday, and new signs on Wednesday, a line graph goes up, down, and then plummets to the baseline.
Right, which makes it look like the client forgot everything they just learned.
Exactly. To fix that visual lie, analysts use a graph that operates on entirely different physics. The cumulative record.
Ah, the cumulative record. It's a brilliant invention, primarily associated with B.F. Skinner's early laboratory work.
And its defining characteristic is that the data path never ever decreases, right?
Never. It operates precisely like the odometer on your car. Every time a new response occurs, it is added to the total number of previous responses.
So the line can only move upward, or it can remain completely horizontal. Let me push back on the visual intuition of that, though. Because if I'm a parent or a teacher, and I'm looking at a student's progress chart, and I see a line that is totally flat for 3 consecutive days, my immediate reaction is panic.
Yeah, a flat line intuitively feels like failure or regression.
Right, a loss of the skill.
And that exact misinterpretation is why reading a cumulative record requires specific training, and it's also why it's a classic trap on the BCBA exams.
Oh, really? Student errors on this are common.
Very common. You have to reprogram how you interpret the visual display. On a cumulative record, a horizontal, flat line does not mean the behavior is decreasing.
It simply means that 0 new responses occurred during that specific observation period.
You got it. So the student didn't lose the 50 spelling words they mastered over the last 3 months. They just didn't master any additional words on Wednesday.
The total volume of knowledge is still securely represented by the overall height of the line.
Precisely. The critical diagnostic feature of a cumulative record is the slope.
So a very steep slope indicates a rapid, high rate of response or skill acquisition.
Right. And a more gradual slope indicates a slower, steady rate. And a flat line indicates a pause in responding.
It's the ultimate tool for visualizing the total accumulation of a repertoire over time. It completely eliminates that false impression of regression.
It's essential for skill tracking.
So we have the daily analysis of the equal interval line graph, the macro summaries of the bar graph, the heat mapping of the scatter plot, and the total accumulation tracker of the cumulative record.
That's a solid toolkit.
But knowing how to interpret these canvases is only half the equation, isn't it? The true test of a behavior analyst is utilizing these visual tools to actively drive precise treatment decisions.
Absolutely. You aren't just an archivist passively logging data. You are the architect of the intervention.
Which requires tools designed for precision. For example, the standard acceleration chart.
Yes, developed by Ogden Lindsley for precision teaching. This chart fundamentally changes the math of the y-axis.
Because it's a semi-logarithmic chart.
Right.
Okay, what does semi-logarithmic actually mean in practical terms for the person charting the data? Because that sounds intimidating.
It's actually pretty straightforward once you see it. An equal interval graph adds or subtracts behavior. So moving from 10 to 20 is an addition of 10.
Yep.
A semi-logarithmic chart multiplies or divides behavior. It charts relative change, tracking the acceleration or deceleration of the rate of responding over time.
So moving from 10 to 20 looks exactly the same as moving from 50 to 100.
Exactly, because in both cases, the rate has doubled. It is specifically designed to visualize how fast a learner is acquiring a skill, aiming for fluency rather than just basic accuracy.
It measures the rate of learning itself. That is an incredibly powerful way to look at human potential.
It really is.
But let's look at a design from the sources that actively puts the graphed data in the driver's seat of the intervention itself. I'm talking about changing criterion designs.
Oh, I love these. This creates a graph that looks like a very distinctive set of ascending or descending stairs.
When do we use those?
We use a changing criterion design when a behavior is already in a client's repertoire, but we need to systematically shape the right duration or frequency of that behavior.
So each step on the graph represents a new, predetermined criterion that the client must meet to access reinforcement.
Yes. The sources outline a highly relatable clinical example for this.
The teenager and the hamper. Imagine a parent trying to increase how often their teenager puts their dirty clothes in the hamper. The baseline data shows it happens maybe once a week.
Typical teenager stuff.
Right. So the parent sets the first criterion. If you put your clothes in the hamper 2 days a week, you get your $10 allowance.
And once the teenager masters that, once the graph data stabilizes at that 2-day mark, the criterion steps up.
The new baseline expectation becomes 3 days a week for the same allowance. Then it steps up to 5 days. Here's where it gets really interesting, though.
Yeah, tell them.
You, as the practitioner, do not get to decide when to move to the next step based on a gut feeling or because you think the client is ready.
The graph actively dictates the pace of the intervention.
You physically cannot advance the criterion to the next step until the data clearly demonstrates that the current step has been mastered and stabilized.
The changing criterion design forces the practitioner to be patient, systematic, and entirely reliant on objective measurement.
It completely removes the guesswork from shaping behavior.
And it holds you accountable to the science, which brings us directly back to the ethical mandates we started with.
Specifically, Code 2.17. Analysts are required to use data to make decisions about continuing, modifying, or terminating services.
If you are running a changing criterion design and the data path has been stagnant on step 2 for 6 weeks,
the graph is practically screaming at you that the intervention needs to be modified. You cannot just coast along, cashing the checks, claiming that, well, they're trying really hard.
the objective data forces ethical action. It strips away our subjective justifications.
Which is so important. Summaries from parents or verbal reports from school staff are absolutely valuable for context, right?
Yeah. Oh, definitely. For understanding the social validity of what we're doing, they're crucial. But they cannot replace the objective graphed data.
The graph protects the client from ineffective treatment, and it protects the practitioner from their own assumptions.
It's the ultimate safeguard.
For today's deep dive into behavioral intelligence con Mara Sánchez, exploring C10, we've integrated some excellent clinical perspectives. And if you're looking for more resources on behavioral intelligence, you can check out the team at Amethyst Therapy Services.
Yes, definitely check them out.
Just visit www.amethysttherapyservices.com or reach out at info@amethysttherapyservices.com, and definitely stay tuned because we will be tackling Section C11, interpreting graph data and trend lines in even more depth in a future deep dive.
It is the necessary next step. Today, we established the vocabulary and the mechanics of the graphs.
Next, we have to look closer at how to synthesize those mechanics. We really have explored the entire landscape of visual analysis today. We started with the underlying philosophy, why we graph to ensure conservative, transparent significance instead of hiding behind statistical manipulations.
We broke down the workhorse equal interval line graph, utilizing the big three of level, trend, and variability.
Right, using those to pinpoint behavioral functions, like Anatoly's escape behavior or Elena's automatic reinforcement.
Then we zoomed out to look at the macro summaries of bar graphs and the temporal heat mapping of scatter plots.
We completely rewired our brains to understand the ever-climbing odometer of the cumulative record.
And finally, we examined how tools like the standard acceleration chart and changing criterion designs enforce ethical, data-driven decisions.
Graphs are not just math on a page. They are the objective visual language of behavior change.
What's fascinating here, and what I want to leave everyone with, is a reminder of the human element in all of this data.
Well, that's a great point.
We have spent this entire discussion establishing how graphs provide an objective picture. But visual analysis inherently relies on a human being interpreting that level, that trend, and that variability.
Yeah, there's always a person looking at the paper.
If you, as a practitioner, have spent weeks designing an intervention, training the staff, and pouring your heart into a case, you desperately want that intervention to work.
You're emotionally invested.
Right. So how might your own internal bias affect what you see when you look at a highly variable data path? Could your eyes accidentally perceive a downward trend in problem behavior simply because you are hoping to see one?
That is the ultimate paradox of visual analysis. The canvas is perfectly objective, but the eyes reading it are profoundly human.
It's the exact reason why strict operational definitions, rigorous data collection, and utilizing independent observers to check your work are so vital to the integrity of the science.
You have to trust the data, but you always have to verify your own vision. Thank you for joining us, and we'll see you on the next Deep Dive.